everyone. Okay, so hi, this is Adriii.A, and I know that some of you don't know me yet, but just want first to share a little more information about me. Okay, so hi, as I said before, this is Adriii.A, and for some of you who don't know that I've done a YouTube vlog before, yes, that's true. I've done a YouTube vlog before, and I just tried it once. And to know if vlogging will be for me or vlogging will be my passion, and it turned out that it's not for me. And I hope that public service will be for me. Yes. So today I have a very special mission to me. So what is it? We all know that our country is under the state of emergency, and the entire region of Luzon is under this enhanced community quarantine as what declared by the government due to the COVID-19 or the coronavirus disease 2019 pandemic. So classes are suspended, and it is part of our mission and our obligation and our responsibility to educate ourselves, to still educate ourselves, and also to help educating other people. So now I have a very special mission to make, and that is to teach you a particular topic in mathematics, and that is reference angles in trigonometric ratio. So later on, I will be discussing to you reference angles in trigonometric ratio. But I just want first to share what are the things or what are the stuffs at my back. And also, I want to take you on a tour at our house. So, stand by. You can see we are now in the south wing of our house where a lot of stuffs are here, just like different kinds of flowers, vegetables, fruits, animals, most yes, the chickens, and a mini basketball court. I know that some of you don't know that I used to play basketball before, but it is currently stopped. They are temporarily stopped because of the condition of my face that I need to prevent any injury regarding on my teeth, most especially yes on my teeth or on my face. So yeah. So now I will now be discussing the reference angles in trigonometric ratios in 5, 4. So I may not be feeling well nowadays, but I will do my best to teach you all about reference angles in trigonometric ratios. But first, a little, I just want to show you my room. Actually, it's not big as what you think, but yes, it is just suitable for me. There, as you can see, there is a television and an electric fan, a bed, and also my table. So here are my table. So these are my tables. Yes, there are 3 because I don't think that one will be enough for me. I mean, in terms of table, don't you worry. In terms of table, not in any other terms. No, but in terms only of table, I don't think that one will be enough for me. So I will be needing 3 tables. Okay, so now let's go on to our lesson. Bye bye. Now I'm back, and I will now be discussing reference angles in trigonometric ratios. You can see, part of our introduction, reference angles in trigonometric ratios. So first, let's define what reference angles in trigonometric ratios is. So according to Google and SparkNotes, the use of reference angle is a way to simplify the calculation of the values of trigonometric functions at various angles. A reference angle for a given angle in standard position is the positive acute angle formed by the x-axis and the terminal side of the given angle. So, as we now encounter reference angles in trigonometric ratios, you will be encountering these words: quadrant, the acronym ACTS, degree, positive, negative, theta, formula, and trigonometric function. And here are the things you need: ball pen or pencil. So now get ball pen or a pencil, paper, calculator, and I think this is one of the most important, your attention, and the most important, your brain cells. Okay, so reference angles in trigonometric ratios. As you can see, there is an x-axis and a y-axis. So, what are these? What are these stuffs? Okay, so later on, I just need a commercial. We will be going back to discuss this all. As we now go back for our topic for today, that is the reference angles in trigonometric ratios. So as you can see, we have here the y-axis and the x-axis, or the vertical and the horizontal axis, and the different Roman numerals. So what do the Roman numerals stand for? So it means the different quadrants. So in Roman numeral number 1, it indicates the quadrant 1. In 2, in Roman numeral number 2, the quadrant number 2. And in 3 and 4 are the quadrants number 3 and 4. So they are written in the counterclockwise position. And now let's go on to the acronym ACTS. So what are the meaning? Or what do the letters stand for? So A, the first word is the A, letter A, means that all functions are positive. So all of the functions that may land on this particular quadrant will be automatically positive. So what are the functions? That is the sine and its counterpart cosecant, cosine and secant, tangent and cotangent. That's the SCT in SOHCAHTOA and the CSC in CHOSHAKAO. And also we have here, and also the ACTS, the acronym ACTS is written in a clockwise rotation. And also each quadrant have their own formulas. So in quadrant number 1, there is no formula, so it means that the theta will just remain. In quadrant number 2, we have the formula here of 180 degrees minus the theta. In quadrant number 3, theta minus 180 degrees, and in cosine and secant, 360 degrees minus theta. So I have here the following brackets. So for you to identify on where quadrant you may belong, we have here the following guidelines or bracket. So now in quadrant number 1, for you to belong on this quadrant, you should be on the bracket of 1 degree to 89 degrees. In quadrant number 2, 91 degrees to 179 degrees. Quadrant number 3, 181 degrees to 269 degrees. And quadrant number 4, 271 degrees to 359 degrees. As you notice, we did not include the following degree, the 0 or the 360 degrees, 90 degrees, 180, and the 270 degrees, because they are part of the line or the y and x axis. So for you to belong, or for you to know on where quadrant you may belong, you just need to follow or to look for this guide. So now let's go on to the following examples. But first, before we answer the examples, we should follow the following steps. Number 1, you should look. Number 2, analyze. Number 3, think. And number 4, follow the formulas. So the direction is to express the following trigonometric ratios of acute angles and find their values correct to 4 significant figures or 4 decimal places. So as we answer the number 1, sine 95 degree or sine 95. So first, we should look for the number 95 degrees and look for the bracket. So as we can see, 95 degrees belongs to the second quadrant, which ranges from 91 degrees to 91 degrees to 179 degrees. So now we should follow the the written formula for the second quadrant, which is 180 degrees minus theta, or 180 degrees minus 95. So 180 minus 95 is equals to 85. Sine 85 is equals to 0.9961. And we should round off it to 0.9962. Ma'am, sir, why didn't you write the negative sign in front or in the answer? We did not write the negative sign on that answer because 95 degrees belongs to the second quadrant. And as you can see, sine and cosecant are the two positive functions that are only allowed, the two only positive functions in this quadrant. So sine and cosecant. So as we can see, the function of 95 degrees is sine. So sine, the second quadrant, is positive. So 0.9962 is our answer. Positive 0.9962. Okay, so now let's go on to the example number 2, tan 280 or tan 280 degrees. So first we must look for the degree or for the number, so 280, and 280 degrees belongs to the quadrant number 4. So if 280 degrees belongs to the quadrant number 4, we must follow the formula of the fourth quadrant. The formula is 360 degrees minus theta, or 360 degrees minus 280. And the answer is 80, or 80 degrees. Then, put in your calculator tan 80 degrees. And the answer will be 5.6712, or you should round off it to 5.6713. And also, why there is the negative sign? We put the negative sign there because 280 belongs to the fourth quadrant, and cosine and the function secant are only the positive functions in this quadrant, and tangent is not belong, or tangent and the remaining functions will be negative already. So cosine and secant only. So we put, because this is a tangent, so we put the negative sign on the answer. So the answer is negative 5.6713. So now let's go on to the third example. And the third example is cosine 80 degrees, or cosine 80. So first you should look for the number 80. And as we can see, 80 degrees belongs to the first quadrant, because the first quadrant first quadrant ranges from 1 degree to 89 degrees, and 80 degrees is part of the first quadrant. And as part of the first quadrant, all functions that may land on this particular quadrant will automatically be positive. And also, there is no formula written, and the theta will be remained. So cosine 80 or cosine 80 degrees is equals to 0.1736, positive 0.1736. Okay, so now let's go on to the fourth example, and that is the tan 230 degrees. So first, you should look on the number, that is the number indicated on the fourth item. So 230 degrees. So you must look here. And as we can see, 230 degrees belongs to the quadrant number 3. So you must follow the formula of the quadrant number 3, and that is the theta minus 180 degrees, or 230 degrees minus 180 degrees is equals to 50 degrees, and tan 50 degrees is equals to 1.1917, or you should round off it to positive 1.1918. The question is, why didn't you write the negative sign on the answer? Well, as we go back to the previous definition of this acronym ACTS, the T, the third quadrant, only tangent and its counterpart cotangent are the positive functions for this quadrant. and the others will automatically be negative. So as you landed here, tan 230. 230 is on the third quadrant, and tan is the function of the third quadrant, then it must be positive. So the answer is positive 1.1918. So now let's go on. Now let's go on to the fifth and last example, and that is the sine 359 or sine 359 or sine 359. Okay, so first you should look for the sine 359 and look for the quadrant of 359. So as we can see, belongs to the quadrant number 4. It is already written here. So 359 degrees must follow the formula of the fourth quadrant, and that is the 360 degrees minus the theta, or 360 degrees minus 359 degrees. And the answer is 1 degree. So sine 1 degree is equals to 0.0174, or you should round off it to 0.0175. So why did we write the negative sign here? Well, because it is only written here that cosine and its counterpart secant are the two functions that should be positive on the fourth quadrant. So 359 belongs here, and you should follow the formula and also the functions. And the function of 359 is sine, and sine, as we all know, belongs to the second quadrant, not in the fourth quadrant. So automatically, all of these functions except cosine and secant should be negative on the fourth quadrant. So the answer should be, or the proper answer should be negative 0.0175. So now, after our discussion, I have a special quiz to leave you. Also for me to know if you understand our lesson for today. So on this direction, its direction is to express the following trigonometric ratios of acute angles and find their values correct to 4 significant figures or 4 decimal places. So number 1, sine 70 degrees, 2, tan 300 degrees, cosine 250 degrees, tan 185 degrees, and sine 110 degrees. And put your answers at the comment box below. Thank you. So that's all. Thank you very much for listening to our lesson for today, and I hope that you learned a lot from our discussion. Thank you for watching this video from Adriii.A. Thank you very much. And also, I have a realization to make later, so watch out for it. Bye-bye! So now, as we ended our lesson for today, I made a lot of realizations about reference angles in trigonometric ratios, and also mathematics is just like life. Our lesson and our subject is just like also life. Mathematics and our life are full of complications. Mathematics is full of complications, full of hardships for you to answer the correct answer. But if you can now distinguish on how to answer the first question, the next items will be easy for you, because you know how to answer all of the questions. Just like life is full of struggles, full of complications, full of hardships, full of downfalls. But if you know how to stand up, if you know how to be strong, if you know how to defeat all of your enemies, nothing is impossible. You can succeed in life, and you can achieve your goals for as fast as you can. So don't lose hope on this matter. Don't lose hope in mathematics. Don't lose hope in life. Because those things teach us to be stronger and to be more hopeful that we can resolve the following problems that we may encounter, not only in the subject of mathematics but also in the real life. So just be strong. on this following or on this circumstances, our country is experiencing a lot of issues, most especially the COVID-19 pandemic. So for all of the people, we should be strong. We should not lose hope that everything we should be strong. We should be hopeful that everything will fall into place and everything will be all right. That's all. Thank you very much for watching this video. I hope that you learned a lot of things from me. This is Adriii.A. Thank you very much for watching. Bye-bye.